All right, everyone, let's get started. This is my talk, Sprinkles of Functional Programming. Before we begin, I'd just like to say a couple of thank yous. First off, thank you very much to Ruby Central for inviting me to come speak today. I'm super thrilled to be here and for yet another amazing Rails conference. Secondly, thank all of you guys for coming and joining me on this first hour of the conference. I'm super excited about this material. It's added a lot of benefits to my programming practice over the past couple years that I've been thinking about these things, and I'm excited to be able to share share it with you. So I'm John. I work at Thoughtbot as a developer, as a consultant. When I first told some of my colleagues that I had a talk accepted into the RailsConf, the very first thing they said was, all the best RailsConf talks have a Twitter slide. It turns out I don't have a Twitter, but I still made you a Twitter slide. That is my real GitHub. If you want to find me on the internet, and I just go by my name, John Schoeman. Cool. So let's just dig into the talk. My goal of this talk is to convince all of you that the ideas and the functional programming style are worth thinking about and bringing into your Rails practice. Could help give a lot of benefits in terms of quality of code, effectiveness of developers. So a roadmap for this talk. We'll start with a thesis, sort of the key point, get that established right off the get-go. We'll talk a little bit about functional programming and object-oriented programming at a very high level. Different people tend to mean different things when they say these terms. They're a bit ambiguous. I'm going to explain to you what I mean when I say those so we can all be on the same page. I'm going to make you a recommendation. It'll be a story that's going to have some code. That is where we will spend most of our time today. And then we'll recap and we'll have an action item to kind of go home with, to try to take home with us. One thing to notice that's not on this roadmap is I am not planning to talk about implementation details of how to write functionally styled code on like a line-by-line basis. So if you have zero exposure to functional programming, that's totally okay. We won't be going over those things in detail, but we will be spending most of our time at a much higher level talking about kind of why and where you might want to consider functional programming. And there'll be a slide at the end with some resources if I'm successful in inspiring you to go learn some more on your own. Good starting points for you. Cool. So let's just dig into the thesis. Hopefully these are points that we can all agree on. First off is Ruby's a general purpose programming language. It's a multi-paradigm programming language. It is excellent at both object-oriented programming and functional programming. We as the developer get to choose which style. As Rubyists, I'm sure we're all very familiar with classes, inheritance, defining methods, inheritance, polymorphism, encapsulation, so on and so forth. But we also have access to things like lambdas. We have the enumerable module. Ruby 2.5 introduced yield self, was aliased to then in 2.6. So building up data pipelines is even more convenient than ever. So more functional ideas are coming in as time goes on. Second point is different paradigms lend themselves to different tasks. Specifically, object-oriented programming tends to be very good at modeling behavior. So where functional programming tends to be pretty good at handling data. Based off of those two points, I'm arguing that we should, as developers, specifically Rails developers, we should be choosing our programming style based off of the task at hand. Doing so will lead to ultimately a better product. What I mean specifically by that, if you'll forgive me from just reading directly off this slide here, is if you're modeling behavior, you should be preferring classes and composition, as where if you are handling data, you should be leveraging data pipelines and folds. Cool. Let's talk a little bit about functional programming, object-oriented programming. I think most people, when they're talking about them, they focus a lot on objects and functions, which is a a great way to categorize different programs in terms of their style. You know, object-oriented programming uses objects as sort of the base unit that we build up more complicated things from, as where functional programming uses functions in that role. And I think especially from an academic perspective, this is very useful. However, in my day-to-day development practice, shipping things, building things, I've found that considering what's difficult to change in the different styles is a more useful distinction to be paying attention to. And to describe that, I have a table here. I'll let you all read it for a moment, and then we will discuss. So given a change that you want to add, say you want to add a new method that is a new behavior, an object-oriented program is one such that is very easy to do. You tend to not need to change existing code. You can just add that method in there, and it works. As we're adding new data, it tends to require some refactoring. You need to pull some stuff apart, put it back together. Functional programming, on the other hand, is the opposite. Adding a new method tends to require some change in your code. As we're adding new data, tends to be easy. You can just do that and move on with your development. So some typical cases for object-oriented programming, anything with modeling in the name usually. So these are your users and your posts, interactions between entities in your business domain, whether that's an admin can edit a comment or your notification systems, things that are nouns that you can kind of point at. Functional programming, typical cases, usually anything with data in the name, like a data transformation, aggregation. These are the moments where you need to be able to take data in some point A and you want to get it to point B, whatever that means. Maybe you have a bit of data, a JSON blob that you got from an API. You need to serialize that. You need to save it in your database somewhere. Maybe you're importing a file, a CSV. Maybe you're generating a report where you have some data that you need to squash down and get an average or something like that. Cool. So with that in mind, you know, this talk was inspired from multiple instances during my career, code that I've written, code that other people have written, and kind of improving that code by bringing some of these concepts of what is difficult to change between the two styles, and it's really added a lot of value, solved a lot of pains, and I've kind of distilled a recommendation sort of based off of those experiences that I'd like to share with you here. So given that methods are easy to add in object-oriented programming, as where data is easy to add in functional programming, if we ask how we expect requirements to change before beginning a given task, specifically if we ask that question based off of the context of our business, whatever problem we're trying to solve, whatever value we're trying to add, particularly considering what users might want in the future, even though that's a hard question to answer. If we do that and then choose our style based off of what we think there, a lot of good things will happen. That's the recommendation. So I've made some pretty strong assertions about what is easy and not easy in the different paradigms. I'd like to illustrate why I think that is with a story. The way this is going to work is I came up with this fictional company with this fictional set of feature requirements. And then I solved them all with an object-oriented approach. And then I kind of turned back the dial and solved them all again with a functional approach, went down a different branch of a sort of choose-your-own-adventure story. So that's what we're going to go through, and then we'll compare and contrast the results at the end of that and see if there's any lessons learned from that narrative. Additionally, there's going to be a lot of code, and I'm going to be going through it really fast. So I'm going to encourage you not to read it any deeper than like a squint test. Anything that is important I'll highlight, but if you're trying to read to 100% comprehension, it'd probably be going too fast for that to be reasonable to expect of yourself. That said, I have all of this code up on a GitHub repo. I'll share the slide at the end. So if you do want to go through it line by line later, that's available to you after the talk. Cool, so let's begin. I'd like for everyone to imagine a Rails app. This is a typical sort of Rails monolith. It's a product for a business. It's medium-sized. Let's say there's 8 developers on the team. There's a product manager. They're practicing Agile. There's a sales team. The nature of the product doesn't matter too much, but for sake of the story, let's make that concrete. In my head, I'm imagining a company that's B2B. They're their application allows for small businesses to come into the product, upload some inventory that they have that they can present to users. So users can come, or present to customers, excuse me. So customers can come and review it, buy their products as a shopping cart of some sort. I'm imagining like if Craigslist and Product Hunt had a baby, something like that. Cool. So here's where we're starting. Currently, users can come to a products index. They can fill out the product that they care about using a typical Rails form. We have typical CRUD. Things have value. In this case, Rails has a value of over 9,000. And awesome. Users can create products, and that's great. We're having tremendous business success. The company's doing well. We're bringing on new clients all the time. The sales team is currently in negotiation with a new client, the biggest one we've ever had. They're so big, in fact, that they have so many products that they have a concern that they need to upload so many products that manually entering all of these is going to be unfeasible. They need to change it every month. It's not going to work. So they asked the sales team, it's like, hey, we have this internal CSV that we use for tracking our inventory. Can we just like put that up on an SFTP server and you guys can kind of import that somehow? And the sales team says, yes, we can do that. So they set a deadline for when this is going to be done. Then they come bring it back to the company, give it to the product manager. It gets put on the roadmap. It gets put into the sprint. The developers start work. The sprint goes well, and they're successful. They end up with a PR. It gets up through code review, gets merged, and we have a new commit, our first commit here, allowing users to upload a CSV of products. A quick look at the code. This company practices TDD. So we'll start with our high-level feature spec. A user visits a root path. They attach a file. In this case, it's a fixture of products, a CSV. They click upload file, and then we make some sort of expectation on the count. We'll have a route for this import where we'll hit a method on our product model where we pass in the file. Again, we'll start with a spec. Again, don't need to read everything in too fine a detail. It's more about the story. We'll start off by stubbing out the CSV. A product calls import with the file path, and we make an expectation. And here's the implementation. All we're going to be doing is iterating over each row of the CSV, massaging the data a little bit, whatever that means. Say we're getting a string for a date. We need to convert that to a date time, titleize the product title, something of that nature, and then we'll leverage Active Record to save this to our database. And that works. Life is good. Here's where we ended up with. We have an imports controller. We added to our product model. For our specs, we added a feature spec, added to a model spec, and we have a fixture. And life is good. Here's a GIF of kind of where we ended up with. We're demoing it to our brand new client, and they are ecstatic. Who knew that uploading CSVs could be so wonderful? Who knew computers could be so amazing? So life is good. A few weeks go by, everyone's happy, people are selling their products, people are making money, life is good. Sales team is in negotiation with a new client. This one's even bigger, even more exciting for the company. But this client here, they don't use CSVs internally. They do everything with Excel. So they ask the sales team, it's like, well, I see you guys can upload CSVs, but what about Excel files? And the sales team is like, yes, we can do that. So they set a deadline, they bring it back to the company, they get it in the roadmap, they get it into the next sprint, developers start work. We're going to start off going down our object-oriented path. First thing we notice is that there's some opportunistic refactoring that we should probably do. It doesn't make too much sense to have the imports in the product model, so we're going to introduce a service object to handle this concern. We'll introduce a product data importer. It's going to have a very similar spec, except this time, instead of calling import on product, we're going to instantiate a product data importer. We're going to instantiate it with passing in the file path to the constructor. We'll call import, and we'll make an expectation on the output. Here's the implementation, very similar to before. Just kind of move this logic elsewhere. Now we have our constructor with our file path. The implementation of reading through the file is the same. Now our controller is going to do that instantiation. We'll call import on the importer. Life is good. But we also notice that there's some separation of concerns that we can introduce. We can pull out the formatting portion of the importing portion here. So we introduce a new service object to handle that, product data formatter. This one, it just builds a data hash from the CSV row so that we can build a product out of it. There's the use of it. Life is good. Here's the implementation. Building up the CSV, processing the data how we need to, returning that data. Life is good. Cool. So now we've done that hard work of doing that refactoring to make the change we want to make easy. So we go ahead, we have a nice place to put this new Excel logic. We'll start again with our spec. Instead of this time, we'll stub out an Excel file as opposed to a CSV. Easy enough to do. Here's the implementation. We'll just case on the file extension, then we'll import whatever type we need to. The thing to notice here is that the initializer, we're now composing with the formatter, so we can swap that out later for other formats if we need to down the line. And that feels good. Cool. So we get that shipped. We have a lot of commits in our history. Developers are productive. Everything's working. The client likes it. And we move on to the next client. This client doesn't really matter if they do CSV or Excel, but they have a different currency format that we need to be able to handle. For whatever reason, they put dollar signs in front of all their prices as opposed to using floats. To each their own. But we need to be able to handle this if we want to be able to import their data. So again, we start work. We notice some opportunities for refactoring, so we're going to introduce some separation of concerns. Doesn't make a lot of sense for the Excel and the CSV importing to kind of live in the same file. We can put those in their own places for maintainability, make them easier to understand. So we'll go ahead and do that. Again, we'll start with a spec, CSV importer. Very similar to what we had before. This time we'll stub out a CSV. Implementation is almost the same. We'll do this similarly for the Excel file. This time we'll stub out the Excel instead, and then we'll pull this implementation out here. We notice that there's a lot of kind of duplication between those two implementations, so we'll abstract a class for them to inherit from. We'll pull out a file importer. We will start with our spec, instantiate the file importer. This one, all we'll do is make sure that someone overwrites the import method that we've provided. Here's the implementation. And now we can share that code amongst the Excel importer and the CSV importer, and life is good. Cool. We'll do something similar with the building up of the data. There's a similar amount of separation of concerns that we can introduce here. We'll start with the product data builder, which the CSV and the Excel will import from. Initialize the formatter, build. We'll have our spec here. We'll be creating a hash of the product data. We'll instantiate the builder, passing it in the formatter. We'll build up the CSV row using the builder. The implementation's nice and simple, easy to understand, easy to test, which is because this is test-driven. We'll do something similar with the Excel builder, except this time it's Excel. Similar implementation. Cool. So we've done all of our refactorings. We've done all of our cleanup of our code. So now we can come in and we can introduce the new currency into our formatter. So that's what we'll do. We'll start with our spec. When the currency has a $sign in front, we will strip the $sign from it. We'll start with some sample data that has the $sign, instantiate our formatter, call format on that data, make an expectation that we're saving it or converting it properly into an integer. And here's the implementation. We'll add a helper method, formatting currency, passing in the data. We'll just g-sub it out. Life is good. And we ship that, we get it in, the new client onboards, and so on and so forth. This continues for the life of the project. We're always adding new clients on, updating our code requirements or feature requirements, and here's kind of where we ended up with over those couple of sprints. We introduced plenty of service objects to sort of handle the separations of concerns. Because we TDD'd, we had specs for all of those as well, so we're well tested. We have a nice test coverage, so we're protected from regression tests, in addition to documentation and other good benefits for testing. Cool. So that worked well. Everything works. Clients are onboarded. Everyone's happy. The code is working. But let's take a step back. Let's reset the clock to the beginning and go down the functional path. Let's explore this other universe where perhaps in this scenario, the developers recently attended RailsConf, where they saw a talk where someone was talking about, well, if you have changes in data requirements, a functional approach might be beneficial. And they think about it for a moment before starting work, and they say, it's like, well, every new client's going to have a different set of data, but the behavior is always going to be the same. We're always going to be importing a CSV, an Excel, whatever, and we're going to be saving that data somewhere. The behavior never changes, but the data will change. So let's try the functional path and see how we like it. So again, our first requirement for our first new client was they wanted to be able to handle Excel. Similarly to the object-oriented approach, we are going to introduce a service, but instead of this time it being a service object, we're going to introduce just a regular service. We'll use a class, but all we'll do is expose a single function. Could have used a module or whatever. The test is going to be similar, but subtly different because we will be using a fixture as opposed to stubbing out our CSV file. So we'll import the fixture, we'll instantiate our importer to get access to that function. We'll call import, passing in the file name, and then we make our expectation on the products that we made that are correct. We'll start by pulling out the existing code from the product model in here, just to remind ourselves it's kind of what we're working with. Cool. Then we'll immediately introduce a data pipeline. We'll refactor that code. Since we're refactoring, the specs don't need to change at all. We can just do the code. This is a bit long, so again, squint test. The thing to notice here is that we have a single public function available to us, importing the file path, and a bunch of private methods in support of that. And let's blow that up to look at it a little bit more closely. So cool, here we have our import function and our process data function, and this is it. This is our sprinkle of functional programming. Just a few lines. Let's go over it real quick. We'll start with reading the file, passing in the file path. This is just going to return an array of data. We're going to iterate over that array, passing the data into our process data function. We'll map over that and create products based off of that process data. One thing to note on this import function just at the top here is that I've separated the I/O from the data processing. Functional programming teaches us to do that. It teaches us to separate our side effects from our pure functions. And that allows me to have this nice clean data pipeline for process data where it's easy to understand, it's easy to test. I'm going to start by processing the dates, and then I will use Ruby's then method to chain on the next processing function that I need. If you haven't come across then yet, it was introduced in Ruby 2.6. Basically, all it's doing is taking the result from whatever you're calling it on, passing it into the block that you provide, and then yielding the results of that block. So this is sort of Ruby's answer to convenient data pipelines, and it works really well. We should all be using it a lot more. Cool. So that's done. So now let's add our new change. We want to be able to add the ability to read from Excel as well as CSV. We'll add a new spec. It's going to be exactly the same as the old spec, except this time our fixture is going to be in Excel, but the format of the spec is exactly the same, where we just have an input, we run our function, we make an expectation on the output. Here's the implementation. Because I've separated the reading from the processing of the data, it's very easy to just kind of slip this in here. I don't need to change any existing code. All I need to do is add the ability to read that file. Again, we'll case on the file extension, and then pipe that data into the process data function. And so long as I maintain the same API that is returning an array of data, nothing else will need to change. And that's it. We ship that. The user can use Excel. And then our next client comes along who needs the ability to add the $sign to their prices. So we will add our next commit, formatting the currency from CSV. This one doesn't require any new specs. All we need to do is update our fixtures such that it includes the data of the different formats that we want. So that's pretty easy. We just open up our CSV fixtures and we add the new data that we need to be able to handle. Implementation of that is similarly pretty straightforward. All we need to do is add a new function at the end of our data pipeline, passing in then, processing the currency, similar solution where we're just going to strip out using gsub, passing in the data, so on and so forth. And that's it. We ship the code, life is good, time moves on, there is much rejoicing and success, people are making money. So a quick recap of where we started and ended. We started with the initial CSV importer, then we had a new requirement, and then a new requirement, and then so on and so forth, as all projects do. So this, like I mentioned earlier, this talk was inspired by some real-life events and improving things. It was really couched in noticing that over time, the real important part was the things that needed to be able to change. And so I knew that introducing some of these ideas led to a lot of benefits in the code bases I was working with. But it was really nice to kind of go through this talk and kind of build up this experiment, which really started out as much as an experiment. I didn't quite know exactly the extent of how beneficial one path over the other would be. So it's nice to be able to kind of do this where we can compare and contrast the results without the noise from other things happening in the project. And so here are a few of the things that I noticed specifically. First off, the code was a lot clearer. If we go back and look at the object-oriented solution where we ended up with, on those just relatively few features added, we ended up with a lot of stuff here. This was particularly difficult for me to load all of this up in my head at one given time to understand what was going on. You can imagine coming back to this in 6 months and needing to spend a lot of time to respin up. Similarly, we had all these specs that we needed to do to maintain spec coverage for all of those. So similar sort of added complexity to our test suite. We compare that to the functional style where we didn't add any models. We added a single product data importer with one input, one sort of output, and that was it. Our tests were similarly more compact. We have more fixtures, but those are relatively easy. You can just open them up and look at them. Cool. Second thing I noticed is there was significantly less code in the functional approach. Here's the total diff, so the total code added at the end of the day from our starting point. It's about a factor of 4 in terms of added code, which was interesting to see, but I think more importantly is the accumulated diff I noticed was significantly higher. So this is the total added difference for each commit added up. So for example, if you had 2 commits, the first one switches 2 lines and the second one undoes those 2 lines. The total diff there would be 0 because nothing changed, but the accumulated diff would be +2 -2 because it was +1 -1 twice. So that's what I mean. And this was just relatively small set of features. I imagine over the life of this project, if we continue adding more clients to our narrative, this would just grow and grow. So that I felt was an interesting tidbit. Third thing I noticed is there's less maintenance. If you consider the number of public APIs that the object-oriented approach added, there was 8 as opposed to functional's 1. All of these are going to need tests. These are going to need to be taken ownership over the life of the project. Anything could rely on these in the future, and we need to pay attention to them moving forward to maintain that they are still useful and accurate objects in our code. The final thing, probably the most important one to me that all the other ones sort of led into, is a significantly higher development velocity. It took me about a day to do the object-oriented approach, as it took me about an hour to accomplish the functional style. I had that one feature spec from the very beginning covering me the whole time, and the functionality was exactly the same. So this is cash money. This is your development time that translates directly into dollars and how productive you can be as an individual contributor, or how productive your team could be coming after you if you start off on this path and choosing the right paradigm. Some other things that I noticed in going through this exercise were some paradigm smells. I thought they were pretty interesting. The first of which was there's a lot of something-er classes here. You know, we have the builder, we have the importer, we have the other builder, we have the formatter, we have the other importer. If we were to keep going, maybe we'd want to add a validator, something of that nature. A something-er class to me reads a verb that I've forced into being a noun. If you think about it for a moment, there is no concept of a builder or formatter in the domain logic for this application. These are implementation details that are masquerading as nouns in our system. They don't actually exist. They're not useful to anybody. But reading these at a glance, you might get confused. And I think this is one of the biggest reasons why it took me longer to do the object-oriented style. I didn't have a real-world concept to reason about, to make a mental model of the world. These didn't map into anything like that, so it was easy to get kind of confused and lost, even over from a couple commits ago. And these are all the classes I added. The second one I noticed is the model diagram ended up being a linked list. If you follow the data through the system that I made, it's a little hard to see as you're adding a single commit, a single PR here and there, but if you look at it holistically from from the end. We start off with the imports controller, which passes to the importer, which delegates to a subset of the importers, passes to a builder, a validator, formatter, ultimately writing to the database. It basically built up a data pipeline anyways. It just is spread across 8 different files now. Cool. Let's talk about some takeaways, high-level lessons from our story. The first of which is it's useful to consider how requirements might change. I think as developers, it's really easy to just get a task and just start doing things because it's fun. We like programming. Like I'm a hobbyist on the side. I do this for fun. This is how I got started. And I like object-oriented programming. It feels very productive, and it's easy to just get going. But if I'm not considering how my code requirements might change, and they will, I pay a cost for that. Second of which is sprinkles. A little just goes a long way. I kind of mean that in 2 ways. The first of which is if you go home and think that the message from this talk was to just completely rewrite your app and do everything in a functional style, that is not it. If you look at the amount of kind of functional code I added, just a handful of lines. You could come up with a similar sort of example where you forced a functional paradigm into a task that really lends itself to object-oriented programming, and you would find similar results in like the opposite way in terms of missed benefits. Taking out a user resource, for example, and trying to put that into a service where it needs to interact with your system is a challenge and would be not a good idea. The second bit I mean by sprinkles is that you don't need to necessarily learn lambda calculus. You don't need to be an expert in Haskell to introduce some of these ideas into your development practice. There's some really easy to approach concepts there that you can go off and learn and bring into your Ruby development right away, and you don't need to get too much farther than that. Finally, I think be conscientious of business goals before starting work. Similarly to kind of thinking about what might change in the future, I think considering the needs of others before you just start doing things goes a long way and goes to being much more productive. And I think one of the themes of the talk that I'm coming away with that's sort of underwriting everything that I've been thinking about is to really avoid ideology. You know, pick the right topic for the task when you get it, and consider how that might affect the business down the line, your peers down the line. So an action item, something to take home with you. Before beginning your next task, ask how you might expect requirements to change. And if it's data, consider a functional style. If it's behavior, consider an object-oriented style. Key thesis to round us off. Ruby's a multi-paradigm language. Different paradigms lend themselves to different tasks, and we should be choosing our style based off of a task. If there's one thing that I'd like for you to take away from this talk, it's this 3 lines here. Like I mentioned earlier, if you're interested in getting a little bit more into functional programming, there's some great resources out there. Gary Bernhardt has a wonderful talk, lesson online, Functional Core Imperative Shell. You can just Google that. ThoughtBot, our blog, we have a lot of great resources from our developers who've explored some of these ideas and made some wonderful blog posts. And then there's another nice talk by Mr. Solinkia for blending functional and object-oriented programming in Ruby. Here's the repo if you're interested in looking at the code in more detail from the examples, sprinklesoffunctionalprogramming.app. And that is the end of my presentation. We have a few more moments if anyone has any questions. Or we can just clap and call it a day. Yeah. Cool. Thank you all very much.